Hello and welcome to the Engineering Career Coach podcast. In this episode, I will be talking to Daniel Brateris, an electrical engineer and engineering educator currently serving as Executive Director of Experiential Learning at the Newark College of Engineering and the Program Coordinator for Electrical and Computer Engineering Technology at the New Jersey Institute of Technology, or NJIT. Under his supervision, NJIT has become a leader in STEM education, running a massive makerspace, participating in Baja SAE, Aero SAE, robotics clubs, and more. We'll be talking about how project-based learning, or PBL, can help students build relationships, plan career paths, impress employers, and build additional skill sets. Now, I'm your host, Jeff Perry. I'm the founder of More Than Engineering, helping engineers and technology professionals with leadership and career coaching to create meaningful careers and lives. And this is the Engineering Career Coach podcast, brought to you by EMI, the first podcast dedicated to helping engineers and technical professionals with both their personal and professional development. Now it's time to jump right into the main segment of this episode. Dan, we're so excited to have you here on the episode. Welcome to the Engineering Career Coach podcast.
Happy to be here.
Now, Dan, as we get started here, I want to hear in your own words, can you tell our listeners a little bit about you, your background, and what your day-to-day looks like these days?
Sure. Yeah. So I work at New Jersey Institute of Technology, and my background is mostly in engineering education and in product design. So when I got my bachelor's degree, a few colleagues of mine, we started a consulting company building things. And we ran that for a number of years, still use it occasionally if there's something that kind of sparks our interest. But primarily I've been in engineering education and a little bit in theatrics and show design, more on the engineering side of those things. And my day-to-day here is basically promoting and administering our hands-on activities at the university. So we have a very strong program in building things, right? So most of what engineers do eventually ends up in the physical world. And depending on the university you go to, the program you study at, you may or may not have a lot of that. And so my job here basically is to make sure that NJIT has a lot of that. So we encourage professors to do things like final projects, maybe instead of final exams. We make sure our laboratories are top notch and that they're used to a very high level. We make sure that there is a practical, hands-on side to all of our engineering education. That includes our makerspace, our student teams, extracurricular activities, and all sorts of things of that nature. So it's a pretty broad job, but we get to have our hands in a lot of different things, and it really makes for a great education here and really making the futures of our engineering students very bright.
That's really great. So obviously you're a big advocate of doing projects, not just exams, and getting hands-on and things like this. And so when we think of it, and we want to go deep into into this topic today, so can you just kind of set the stage for us? Can you explain what project-based learning really is all about?
Yeah. So project-based learning, some people, kind of abbreviate that PBL, is a way that we try to structure what people are going to learn by creating a project that we know is going to lead them down the path of learning those topics. So, one structure is to take a textbook or your instructor, and plan your curriculum out for, the whole semester. We're going to cover this topic, this topic, this topic. And another thing is to maybe start with a project, or maybe midway through the semester, start with a project that we know is going to require these skills and these areas of expertise and these areas of learning. So in order to be successful in that project, we are going to have to learn those material. And that does tend to work very well because it gives a lot of context towards what you're learning. I'm an electrical engineer, so if you learn circuits 1, you spend a lot of time on Ohm's law, but you may not understand why that is completely relevant, right? So that's a simple example, but if you find a way that is necessary to make a portion of a project work, it brings a lot of context to it. And you can do these kind of projects with very small, simple tasks, almost like lab experiments, to full semester or multi-year long projects where the students are building something piece by piece and they're learning the theory and content as they go along.
Okay, so when we're thinking about this in the context of the education world, we're trying to prepare these students with the skill sets and also building relationships and the connections. And you're talking about kind of contextualizing the learning. But what do you think it really comes down to, like when we're working on project-based stuff or hands-on learning? How do you think this really helps students build those relationships and improve those skill sets that they really need to be successful once they leave the university?
Sure. So, I mean, you can break down what happens when you leave a university, I think, into a couple areas. One is your ability to, survive a job interview and impress someone. And then another is to be successful once you have gotten that job. And those are two very different tasks. So one is selling yourself and, communicating to someone that you are going to be a proficient engineer. And the other is actually being one. So project-based learning and in general making sure that we do things in our education that take things away from theory or use theory to actually do something can do that in a lot of ways. So one way that projects do this is if you have group projects and you structure them properly, students have to communicate with each other. They have to manage their time. They have to learn to document what they're doing. And if they do that several times before they leave their educational institution, they have got some practice at doing that. And that's a critical skill, managing your time, managing a project, knowing what to work on next. Those are critical skills for being a good employee or a good engineer or being a part of a team. And then there are other things like, let's talk about maybe interview skills or what you do on an interview. So you can talk a lot about what you have studied in your career, which is typically for an entry-level engineer, is typically your education, right? So you can imagine that many of those interviews are similar from one to the next because most educational careers, at an engineering institution are somewhat similar. These curriculum are very, very structured. There's a lot of material in a short period of time, and it doesn't differ that much from place to place.
They kind of have to be because of accreditation and things like that, right?
Yeah. So accreditation is a big part of that, and then it also is the fundamental science that you need to learn. There, to call yourself an electrical engineer or a mechanical engineer, there's just certain things you need to know, and there's a lot of it, and most places only 4 years, so you can only structure that in so many ways. So what you can do though is if you can contextualize that and show that you understand it to someone that is maybe giving you an interview, then you put yourself above other people who can only talk about what they did in the classroom. And so if you can enrich that classroom experience, or you can bring that beyond just laboratory experiments, the students can talk about this in a much more rich way that shows their understanding of the material much better. So a good example is we have a lot of student teams here, and they typically build vehicles, solar cars, airplanes, all sorts of different types of products. And when you sit with one of these students and you ask them to tell you what they do, all of a sudden they can take everything they know about that project and they can start relating it to fundamental concepts. They can start saying, I worked on this part of the system, and I had to coordinate with this sub team. I had to coordinate with the budget. I had to coordinate with X, Y, and Z. And that starts to bring, real world things into the project. And when you talk about that with an interviewer, or you talk about that with someone who is looking to hire you, it brings them much closer to understanding how you think and how you manage things and how you can, maybe be a part of their team. And so I think that helps our students a lot. A whole lot.
Yeah. And I just think back to my own educational experiences. Like, I don't have fond memories of any of the particular classes I took, but I do remember the projects I worked on, the things that I built and created. And those are the stories that I tell. And also like you're talking about, the connections of the people that you're working with. And it's a huge deal when I think about trying to get into careers and be successful there. Like having those stories to tell about the projects you've created and the things you've built and done. You're talking about interviews and things like that. That's a huge deal, instead of like, hey, I took these classes. Okay, what does that mean? What did you do? Well, projects give you something like said, hey, you did and you built something. It's a big deal. But I imagine on the other side, though, this is probably a shift for instructors and professors, right? So thinking about, hey, maybe they've done kind of the same basic syllabus for the last 5, 10, 20 years, whatever that is. And now they need to shift how they're teaching and the projects and how they're consulting with these students to move them through the educational experience. What are some of the challenges that they're facing as they're adjusting to this different approach?
Yeah. So this from the back end side, right? The people on the educator side, this is one of the biggest challenges for us. I really can't understate how, or excuse me, I really can't overstate how big of a problem that is. It's not a problem of people's desire. It's the knowledge of how to do that. So,
Right.
you end up at an institution like this with a wide blend of people who are teaching, from full-time research faculty to full-time teaching faculty to adjunct instructors. And everyone's a little different, and they may have been doing things very similarly.
Mm-hmm.
So the process of helping these instructors learn a new way to teach or restructure their curriculum so that it can still be accredited, and so that it can fit into their schedules and the schedules of the university and the schedules of the labs. It's a very big effort. But what we typically have done here is we started with a central facility on our campus, which we call the Makerspace, and it's a massive facility. It's about 25,000 square feet, and it's well staffed with full-time engineers who are staff members here, but also have engineering degrees or fabrication degrees or design degrees. And it's also filled with our best and our brightest undergraduate students who come to work in this space. And so what this space ends up doing is providing sort of a guide for the faculty and the instructors. So we hold training sessions in this facility. We hold little micro training sessions that can only be a half hour to an hour long, or we hold multi-day training sessions where we bring our faculty into this facility and we essentially do what we'd like them to do. We take a couple concepts. We say, we'd like you to learn how to do these couple things, and we're going to do something fun. We're going to build a project over the next 2 days, and we're going to show you how we can integrate these engineering concepts into building this project. So a lot of it is almost like show and tell. Like, this is one way we do this. We're going to give you the tools. We're going to give you the support. And then we are here to help as you want to do this in your own class. And it is not a small effort. It is a massive effort. But the results and the rewards are great, as we do it more and more in more of our classes and more across our campus.
Okay, well that's excellent, and yeah, it's a big shift, I imagine, for those educators, and for anyone who's watching the YouTube video of this, you can see probably part of the makerspace just right behind you. But that's just a little bit of it, is you've got a bunch of space and all sorts of technologies that you're working with. So as we kind of break it down, though, so think about if we're just starting, whether you're a university or you're a student, and you're saying, hey, I'm in these classes, or I want to see what I can build and do as I'm going through my engineering education. Or maybe we're also talking to universities or educators thinking about, okay, maybe I want to do more of this project-based learning. What are the essential elements? Like, where do you start? What are the things that really need to be there for you to do this successfully?
Okay, so project-based learning is it's a simple concept, but if you Google that, or if you go to Google Scholar and you Google that, you will find tens of thousands of research papers. So one thing is, you can look at the body of research that's out there, and you can see lots of studies that show what has worked and what hasn't worked. But if you're starting on your own, the first thing I would say is keep it simple. Don't shoot for the moon. It can end up being a lot of work, but it's one of these things where, as engineers, we know that oftentimes our first idea is not the idea we end up with knowing it works, right? We're designers, we build things. So we have this concept in our facility here where we teach people to prototype. And the concept we have is, your first concept is almost never right. So you're almost essential. You almost know that you're going to fail at some point, and your first concept is likely to fail. So you're going to fail. So don't fail. Don't put a ton of effort into failing. So fail fast and fail cheap. And what that means to us is, take your idea and test it as small as possible and make sure it works for you. So if you're going to start down the path of project-based learning, don't go in with, grandiose plans on day one. Go in with a small plan. I'm going to do a small project, a small concept. I want to teach this concept, and we're going to use this small project to do it. and you will learn a lot of skills on your own, and your students will learn in doing that. And then you can now come back with a slightly larger one, and you can build that way. It is very difficult to go from not doing projects or project-based learning to jumping right in full scale and get it right the first time. And if you get a massive effort wrong, both the instructor and the students don't benefit from that. So if you're teaching well now, just start bringing small things in, and learning from them. And in a year's time, you'll be an expert at it, and you'll be able to build more and more advanced type of projects that you can bring in. So the first advice is start small. And the second advice is to work with what you have. You can ask your administration, you can ask your faculty for money to do things, but I would say that you start small. We are very lucky to have a very, very full featured space here where we can prototype all sorts of things.
Right.
And a lot of people and a lot of institutions think that this is where you have to go. And this is great. And we can do a lot of education in a space like this. But if we didn't have these resources, the goal is not to start by shooting for the moon. It's to just start, right? So if you can't get, $100,000 to buy a big milling machine, you're much better off with $5,000 and buying, a few 3D printers and a laser cutter and starting something than waiting for all of that money to do something big. So I would say start small and just start. You miss 100% of the shots you don't take, right? So start. That's the goal. Start small, start easy, and then build, step by step.
Yeah, and maybe if you're a student, I just think about the many students I've talked to, and some are at universities where kind of the standard education is almost all theory, and maybe the only project they do as part of their education is a capstone project.
Okay.
If that's even there. And so just thinking about, but almost every university has some maker, machine shop or fabrication resources of some sort, even if it is small. And so from the student side, like, hey, even if it's not part of what you're being asked to do through your standard education, look for opportunities to do these things
Absolutely.
as well, even if they're not given to you. Like, look to build and apply these things and build some projects, get together with some friends and decide on something you want to build and go do it, because that's going to solidify and expand your educational experience so much more than just the calculations you're going to run in class.
Yeah, I absolutely agree with that. Yeah, and just to find those extracurricular things to do, or to even start them on your own, is critical if you don't have it, right? And I can give the same advice to those students. If your university doesn't have a massive prototyping space or a massive project space, the best thing is to start small. If you go to your administration and ask for the moon, you're not going to get it on day one, right? But if you ask for something small and you show that you're doing something good with it, the likelihood is you'll get attention, and they will see that you're doing something good with it, and then you'll get more resources. So, and then these clubs that exist on campus usually get some resources from the student senate or the student activities council, things like that. And sometimes starting one of those clubs can get you some funds, and then you can use that. And there's opportunity there. You just need the desire and to start.
Yeah, and that's a great point. Like whether it's clubs or other things, like sometimes I've been involved in things like business plan competitions and other things. So you can find a target, something you want to move towards, even that's outside of the normal educational class, which is great to include that in the classes. But hey, there's always other things, extra projects, competitions, other things that are nationwide, worldwide in some cases, that you can get involved in and shoot towards and build these projects, and finding those opportunities to do that. I imagine, you run a large academic makerspace, but do you ever collaborate? Sometimes there are other like local community makerspaces and stuff like that. Do you ever interact with some of those spaces or talk to some of them?
Yeah, we do. And before we built this space, we went and visited many commercial and academic makerspaces in the country. And we're in Newark, New Jersey, so there are a couple little spaces in the city here. And then in the cities surrounding us, we're very close to New York and not too far from Philadelphia. And there are some really nice maker spaces in those cities as well. And then if you're, depends on what you're looking for, but there are maker clubs in a lot of the high schools and local municipalities in the area. And so we typically try to support them the best we can. Like we have capabilities that they just don't have, right? So we will help them with things that they can't do. So what you'll see is the semester is just kind of falling off here. We're just about through finals. And but high schools are still going for another 2 months, and their competitions like the high school robotics clubs and things like that, they're all coming up in the next couple of weeks. And so they're all scrambling to build that stuff. And so what typically we see is in the next few weeks, we start getting tons of emails from high schools. Hey, we need to water jet this part. We need to do this. We need to do that. We don't have. And so we end up doing a lot of, outreach with those kind of clubs in the area here. And so it does form a nice, it forms a nice kind of network of different education levels and different communities that come and work together. Yeah,
and that's very cool, and that helps fuel the university education programs. Some of those high school students come into the makerspace and like, wow, this is awesome. This is where I want to come and do my projects in the future as well. So that gets them excited, I imagine, as well. Plus, just supporting these educational experiences, no matter who they are, whether they're part of the university ecosystem or not, which is excellent.
I mean, that's our goal. We're a university, but our goal is education, right? It's not to operate this place; it's to educate people. So and to help build careers and build paths for people. And it sounds kind of corny, but it's to change lives, right? We have a lot of first generation students. Sure. And they're the first student in their family to go to college, and so it really, getting a good quality, affordable engineering education is a world changer for many people. So that's our goal, and to do it the best we can.
Okay, very good. As we wrap up this main segment of the episode, any final pieces of advice you would give to students or educators in terms of PBL and project-based learning?
I mean, I'm a little biased because it's what we do here, but for me, I couldn't overstate the value that can be added by participating in these kind of learning activities. Everything from building friendships to building skills to helping your academics. It's funny. You see these teams. We have a lot of these extracurricular teams, and you'll see them in spaces like our makerspace building things, and then there's a couple points in the year where it's like midterm and exam season. And so normally you see them in here with their hands dirty and they're building something and designing something. And then, there's this 1 or 2 weeks where they're all here helping each other learn. So, these clubs and these projects and these teams are good relationships. They help you both socially and academically because you learn to learn from each other. And then you add a whole nother skill set. If you leave an engineering education having an engineering degree and a set of skills in project management and fabrication and prototyping, you are a whole world apart from someone who sat in a classroom and learned the theory. And dare I say that even if they know the theory a tiny bit better than you probably have a leg up, because theory is, in a way, if you don't understand how that theory makes it into the real world, you can be very dangerous with just theory. So you need both. And if you have a balance of both, you are in a very strong position. So I would encourage everyone to try and everyone to try to build things, and especially if you want to be an engineer. So I think it's a great place to start. It's a great place to enrich your education and your life and your friendships. And definitely biased on it, but I think it's a good use of your time and to learn those skills.
Yeah, excellent. Okay, at this point, we're going to transition into the Take Action Today segment of the show, where we'll get one final piece of actionable advice from Daniel. So we'll be right back. Now it's time for our Take Action Today segment of the show. Dan, we've had a great conversation today about project-based learning and the benefits for educators and students through the whole educational process and how that can help Now, what's the final thing you would say, especially to engineering students or people who are starting their career and things like that? What would you say to them about how to jump in and make the most of their educational experience?
Yeah, so I think my advice would be if you're not involved on campus in one of these clubs that does something, and it doesn't necessarily have to be making, or it doesn't necessarily have to be completely engineering related, but if it is to get involved. It's probably the summertime now, so you can usually go and find a list of these clubs and go find out when they're going to meet. They're going to be recruiting new members in the fall, it's both a social and an academic benefit for you. So, if you're not doing one of these things now, get involved. And if you have some burning interest and you just can't find a club on your campus, then go to your student government or go to your administration and say, look, I want to do this. And us educators, if we're sitting in our office, we could be intimidating, but typically we are in this business because we like our students. So come to us and tell us what you want to do. And, hopefully, and if it were me, we would, but hopefully we will find a way to support you so that you can learn these things and be productive. So I would say just, it's a little bit corny advice, but get involved, go and do these things. You're not in college forever, and these things can make a real impact. So go and get involved and start.
Yeah, well, that's excellent. Thanks for a great conversation today. We hope those who listen and tuned in get a lot out of this. If people want to go deeper or learn more about NJIT and the things that you're doing, or project-based learning in general, what are the places that you would send them to learn more or connect with you personally?
Yeah, absolutely. So I work for the Newark College of Engineering at NJIT. And you can find our makerspace at njitmakerspace.com. And there you can get all information about the programs that we run in this space and in our College of Engineering. And if you want to just find out more about NJIT, you can just go to njit.edu. If you want to get in touch with me, I don't know if you can put a graphic up, but you can email me. My email is Brateris, my last name, BRATERIS at njit.edu. And I'm always happy to help anyone who's trying to get an engineering education. So feel free to reach out to me, and I wish you guys good luck.
All right, very good. And we'll have all those resources in the show notes and everything too, and all the links there on the website. But thanks so much, Daniel. It's been a great conversation being with you here today, and thanks so much for taking your time.
You're very welcome. Thanks much.
I really hope you enjoyed the episode today. We would love to hear your feedback, comments, and questions. You can go to www.engineeringmanagementinstitute.org, where you'll find a summary of the key points discussed in the episode, as well as links to any of the resources, websites, or books that we mentioned. And don't forget to check out any upcoming live webinars, also at engineeringmanagementinstitute.org. Additionally, for any engineers who are struggling and need help taking the next career step, I've created some free training resources with an opportunity to join a more intensive program called the Engineering Career Accelerator. You can find more information at engineeringcareeraccelerator.com. Until next time, I wish you the best in all of your engineering endeavors.